Good afternoon, and thank you. It's very exciting for me to be out here. It is my first time here in Korea, and also looking forward to heading over to Japan this weekend for the Grand Prix to go and see how our friends at McLaren get on this weekend. So my name is Edward Green. I am Head of Sponsorship Technology. 8 months ago, I used to work for McLaren. I was sat in your shoes. I was a customer, like many of you, consuming all of Cisco's technology, and now my role is inside Cisco to deploy that same technology, but with our sponsors, the likes of the NFL, Golf, Live Nation, McLaren, Riot Games. So I like to think I have a pretty fun job and get to see some exciting customers. I thought what I would do today is walk you through a little bit about McLaren Racing and how they use Cisco technology ultimately to go faster on track, and also explain a little bit about what goes into setting up an F1 race behind the scenes and where Cisco gets used. Many of you will know McLaren for their Formula One team, and these are the cars they take around the world, racing in over 24 different countries when the season starts in March and finishes up in December. It's incredibly exciting, it's incredibly fast-paced, but it also puts huge demands on our team. What I love about sports is the checkered flag will drop at 3 o'clock. The Super Bowl will start at 5 p.m. in the evening. The games will all take place. There is no moving the start time of these events. You have to be ready, and your technology and your products also have to be ready to service these customers in the most extreme environments they see out there. In some of these environments, in Formula One, for example, such as in the Singapore Grand Prix, the ambient temperature behind the scenes in the garage, where the team operates a mobile data center, reaches over 40 degrees Celsius. That is not the temperature you are meant to run your Cisco switches at, but I can promise you it does still work, and the Cisco team are very happy and capable, able to support. Another part of McLaren's journey is also operating across esports. And at Cisco, we're able to support the team in their esports ambitions, as well as also supporting our friends at Riot Games. Esports is an absolutely incredible and amazing opportunity for us to push our technology. The latency that the gaming teams require gets down to 0 ping and 0 latency. And this has really pushed and challenged us from a technical perspective. In fact, now, a lot of the technology deployed across esports is the same technology you'll see in service providers, reaching that 0 ping or zero latency requirements that they demand from us. And so it's an exciting and challenging area. Some of you may have seen just outside this room, there is a racing simulator connected to Splunk. If you haven't had a go yet, please do go and have a try. Not only do you get to see and explore the circuits and drive the game, but all of that data that you see on screen is also coming out of the game, and it's being read into Splunk, and that's exactly what the team here at McLaren Esports do. Unlike the real world, there is no GPS data loss. You're able to run the cars at any time of day or night, and you get all of that data coming at about 20 hertz into instances like Splunk. And so if any of you are deploying Splunk or looking at it or trying to explore it with your engineers in your organization, I'd highly recommend asking for a gaming simulator. If you don't have one in your office already, speak to Cisco, I'm sure we can help you out. And deploy the gaming simulator. Get engineers working on telemetry. Get them working on not network logs, but get them working on their brake pedal, their accelerating. Get them working on predicting lap times. It's a really exciting way to use technology and use products from Cisco. And in fact, the McLaren esports team 2 years ago went on to win the championship. So much of the data coming out of these games is completely flawless. And it is the same data points you get from the Formula One car. So it's a really good and fun way. And our teams, there is no shortage of engineers in Cisco that want to help support these types of events. But as I said, if you've not had a chance, please outside go and speak to the Splunk team and try setting your own lap time and see where your telemetry appears inside Splunk as well. The team also operates across North America in IndyCar, so McLaren is now operating across multiple different continents and has even more challenges, even less time to make change in their network. And IndyCar is benefiting from a lot of the innovation coming from Formula One. Beyond that, they also operate in an electric series, an electric off-road series, where the cars get nice and muddy for once. These are hydrogen-powered 4x4 off-roading cars. The team is gender balanced, so they have both a male and female driver that swap over halfway through, as well as the engineering force behind the scenes is also split 50% between the two genders. It's exciting for us to get to work on these kind of projects because it pushes us to think about sustainability. It pushes us to think about developing the next kind of engineers coming through the organization. And Cisco have partnered with McLaren to make sure we bring through a program called 60 Scholars. We bring through 60 young women each year to get to work on programs like this. This program is so sustainable, the drivers even take their own cutlery with them to races and have to wash it up after the races. And then finally, moving into electric series, this is Formula E. The team have now entered their third season in Formula E. And just to give you some behind-the-scenes stats, the drivers in Formula E will spend 140 days in the simulator in the UK, in Woking. The Formula One drivers will probably spend about 10. So they are spending 14 times the amount of time in the simulators working out when to regenerate the braking, when that kinetic energy can feed back to charge the batteries up. All of that done through beeps in their helmets. So a huge amount of technology, and this is where it all starts for the team. This is back at base in England. This is where the McLaren Formula One team operate out of. This is the McLaren Technology Centre, just about 20 minutes outside Heathrow. Look out for it the next time you come into London. And it's here where the Formula One cars start, and it's here where the networking, the AI, the security challenges that really start for us as well. Inside this building is where they start to design the cars using computer-aided design. 90% of the car's life will be spent in a digital format. So engineers will work on refining those parts, designing new components, designing new capabilities, different weights, different stresses. But 90% of a part's life is spent digitally inside this building. The engineers, between the start of the season and the end of the season, will change 80% of the car. That's over 75,000 components on the Formula One car will change between March and December. Roughly, that means every 17 minutes, a new part of the car is designed. That's a huge amount of change. Imagine the next time you got on an airplane and thought, has a new component been designed between the last time I got on this aircraft and the next time? The pace of innovation and engineering is absolutely massive inside Formula One. But once you've designed a part digitally, it's time to test out if it works in a physical sense. And at that moment, the Formula One team will print that part in 3D, in resin, at 60% scale. So they will take the part that has been through that virtual wind tunnel. It's been in a very highly regulated wind tunnel, chocked full of GPUs to do analysis on that part in a digital format. If all of that looks good, they will then move that into a 3D printed 60% scale model. Between the physical wind tunnel and the digital wind tunnel, they will generate about 6 petabytes of data on any given week. Naturally, they don't keep all of it, but they generate a huge amount of data in just 1 week alone, analyzing between the digital world and the physical world, does that data start to match and correlate? Once they have done that, they are then able to move from the printed world into manufacturing, and they will start producing those parts for the real Formula One cars. The floor of the car, for example, can take up to 6 weeks to manufacture and cost just shy of $1 million of labor and materials to go into it. So you cannot get the data wrong. It is so important that data underpins that decision-making, especially when there is a budget within the sport. It's a particularly beautiful building. We can have some shots of it here from the air. But it's a challenge for people, right? As everyone's returned back to the office, the team at McLaren have really thought about their workplace. They now have a gym in the basement. They have new food menus to keep everyone active. And whilst it looks very pretty, and the gym might be very nice, and the food might be great, it's a total nightmare to put Wi-Fi in a glass and metal building in somewhere like this. It's also a challenge to put in collaboration. When they built this building back in 1998, so it's over 25 years old now, they didn't think that there would be TV screens or video cameras inside meeting rooms. And so in some cases, we had to channel out concrete in the floors just to put in the new WebEx units into those rooms. But the team were able to do that. And last season, McLaren actually won the Constructors' Championship. But not only did they do that in a championship-winning year, they were able to remove their old Cisco network, remove over 15 years of legacy, and midway through the season in August last year, they installed an entirely brand new Cisco network, wired, wireless, data center. And so my challenge is if anyone out there thinks they cannot install a new network mid-year, if you think you can't stop in a bank, in a hospital, well, if these guys can do it, I promise you, anybody in this room can. They had a fantastic mix of partners. And so if you can install a brand new network midway through a race season for 1,000 people, then anything is possible. But back to racing. So this is where it happens for the team. 24 different races, over 19 countries, with 120 people traveling to every single Grand Prix. It's 120 people on the road for most of the season. And in some cases, those folk never even come back to the factory. So when we have to think about support and maintenance and how to keep those people connected, it can be a real challenge. As an IT department, they only have 34 people. In fact, that's 33 because I left last year, so it's a little bit less now. And they do all of this in a budget cap of $140 million. So when they think about how they use AI, with a very small team servicing 1,200 people across all those different racing formats, they have to look at AI. They have to look at the features, the technology coming, and relying upon the AI features coming from Cisco, whether or not that's in how they manage the network or how they respond to security threats. AI helps augment the team so they can focus on the things that will make them go faster on track. This weekend, if you tune in and watch the Grand Prix, you will see 2 cars going around a track in Suzuka, and you won't think very much of it. But on board those cars is an electronic control unit, an IoT edge device. It has 300 sensors connected to it at any one point in time, reading at anything from 10 hertz, a very low refresh rate, all the way up to 80 hertz, which is an incredibly high refresh rate. That means over the course of the race weekend, they will generate 1.5 terabytes of data, with over 250 million data points per car coming in. As the cars go around the track, they are connected to a wireless network at 2 megabits per second back to the garage. So all that data is being analyzed in real time back inside the garage. In here, they have a traveling mobile data center. It flies with the team on the plane. It gets bumped around. Sometimes DHL drop it. Sometimes they don't. But here, they take with them lots of edge compute, networking, storage, and they have to operate a mobile data center wherever they go in the world. When you want to talk about resilience, with 120 people traveling, with over 60 tons of freight, they need to make sure they're fully resilient, and they cannot rely upon connectivity from local tracks. Some cases, these racetracks are fields or part of a street circuit for 360 days a year, and for 5 days, they need to become hyper-connected. So in order to make sure they're fully resilient, the team take with them a traveling mobile data center. They've got to cool it, and as I said in Singapore, sometimes that gets really hot, and sometimes in London and the UK, you don't have to worry about it. All of that is then connected back to a group of engineers in the UK. So that office you saw with all the water and the lake outside, that garage is connected to that environment over a 100 meg MPLS link. So in 24 locations across the world, a single 100 meg MPLS link is provided for 3 days wherever they go racing. That allows all of the engineers back in the UK to stay connected to that data as it comes off the cars. One of the benefits is it's nice and cool, it's calm, it's air conditioning, and that means you can make decisions without all the noise of the fans or the drivers or all of the emotion that happens at track. But it also means the team can take care of all of the additional work they want to do, running all the modeling and simulation in their on-site data centers, leveraging that brand new network the team just installed last year. And in certain cases, when the workloads are high, they'll burst into the cloud to run additional simulations before a race weekend, particularly if it's raining. So this is a good example, right? Some of you may have seen this slide before, some of you may not. But in that complexity of their network, if you think they're racing in Suzuka this weekend, next weekend they'll be in Bahrain. 2 weeks ago, they were racing in China. They don't own all of that infrastructure. If the team are connecting to Salesforce, talking to 365 in the cloud, talking to Dropbox, working in Google Cloud, they don't know often where all of that connectivity is coming from. And so we're able to deploy things like Thousand Eyes to help the team see exactly where all of those challenges in the network may come from or what might be causing the highest latency. Thousand Eyes took 3 days to deploy. It's deployed across the engineering island, it's deployed across the pit wall, and it's also deployed across back at the factory to see exactly how the latency performs. But Thousand Eyes is invaluable to the team to help them make sure they go racing. And if you've got a problem as an engineer and you hit the IT radio button, you don't always give the best description. With Thousand Eyes, the team can see exactly where those problems are before someone on the pit wall even hits a button to say there's a challenge with telemetry. And this is where the team work from. This is their office at Track. This office will look the same whether or not you're racing in Japan, you're racing in Las Vegas, or you're racing in Silverstone in England. This is their office. This is where they have to work from. Here is the team on a Saturday night ahead of the Grand Prix. And you can see the engineering island in the middle there with Kenny texting away on his phone. They expect to be connected wirelessly. They expected to be able to access their files, their information, wherever they go racing in the world. This is their workplace. They don't come back to the factory. This is where they operate from. They need to be able to collaborate, be able to do all the things you do, but from a mobile data center and a pop-up garage anywhere across the world. This is truly their work from anywhere. It's not a stadium. If we can click forward one slide. Right? It's not a campus, it's not a branch. It's a trailer, it's a hotel room, it's the airport lounge. This team is truly on the road working from anywhere, and collaboration needs to happen pretty seamlessly for them. Using things like WebEx, the team are able to go in and see exactly what device you're connecting to the meeting on. They can also see the type of experience, whether or not the hotel Wi-Fi is good enough. They can get ahead of those challenges and make sure the appropriate arrangements are put in place. But this team has to make sure they deploy WebEx units in the drivers' rooms at Track, in the management offices. In some cases, they have big WebEx units covering the entire engineering office, as well as a brand new WebEx suite across the factory as well. What you don't see listed on there is a trailer. You don't see listed an airport lounge. But that's where the team have to work from, and in some cases do their best design work, strategy work, marketing planning, fan engagement, you name it. They are truly doing this from anywhere. With all of that data coming through, this is where the decision-making happens. And in some cases, the decisions this team have to make take place in about 3 seconds. Imagine if there was a crash on the track, and you have to decide if the safety car's coming out, you've got 3 seconds to make a decision. Do you come into the pit lane and change your tires? Do you try and stay out? What are your competitors going to do? You have 3 seconds to make that decision. Now, the people on that pit wall are super smart people, but 3 seconds for anybody to make a decision is really tough and really challenging. And so, in this environment, the team leverage AI. They will run 300 million simulations of the race ahead of a race weekend. So any scenario they see happening on track, they've got a plan for it. They've got a AI model feeding them information on the pit wall. All of that information coming through needs low latency networking. It needs all of those GPUs inside the data centers back in the UK, back at Woking, to be as fast as possible. There'll be no limits between the GPUs and the RAM, no limits between the GPUs and the storage, no limits between all of that compute and the engineers themselves sat on the pit wall. So AI plays a massively important part in the strategy for this team out on track. It also plays a really important role across how they design the cars, using AI to come up with new models, to come up with new designs for the cars. They also use AI for competitor insights. All of those radio messages between the drivers and the pit wall, you can listen into them, and they will use AI to transcribe, to understand the sentiment, to see if Max Verstappen is really that upset on the radio, or if people are trying to get false information to trick each other out on track. They will use AI to make sure they've got the best strategy possible. And so if they've got this future-proof workplace where they're working from the garage, and they have this AI-ready data center where they can take advantage of GPU and leverage strategy, well, there's no reason to do all of that unless you can make sure it's resilient. And that's where the team use Splunk on top of it to make sure they can see what's happening inside those environments. If you take 140 people on the road, all that equipment, you run all these models, but you don't monitor it, you don't protect it, and you don't understand and observe what's going on inside it, and there's no point going racing. And so the team will use Splunk across the entire stack, from the databases they use inside the wind tunnel, to observing connectivity to the website, all the way through to understanding how each machine on the pit wall is working, so that in the weekend they have the maximum chance to go and score as many points as possible and go on to win the Constructors or even maybe the Drivers' Championship. Behind the scenes in the racetrack is 2 IT engineers on the site, but in fact a lot of the support work from an IT perspective happens all the way back here in Mission Control in Woking. And this is what Mission Control looks like. If you've seen Apollo 13, you've seen Mission Control. Some things to point out to you into this room. The room is split, so one half of the room looks after one driver, one half of the room will look after another driver. This is during a race simulation, during a planning session. There's not often someone stood down there at the front, but all of these people will be staring at their screens, intently listening to what's going on in the race. The TV feed is 4 seconds behind the data that we get as a Formula One team. So often you will see engineers looking down at their screens, and they will see something happen. They might see a crash happen on the data. They'll all look up and then watch it happen on the TV 4 seconds later. Sometimes people are so intently focused on what they're doing, we have to make the room glow and look like different scenarios. So you'll see along the top there, it's kind of a LED orange-looking glow. Well, when the flag goes green, the room pulsates green. If there's a yellow flag, the room will start pulsating yellow. All of those environmental cues help people focus on making sure they do what they do best. The racetrack is laid out like an oval, so we can see the gaps between drivers really clearly, but we have to make sure all of that data comes back into this room. And when you watch the race this weekend, if you see the 2 drivers come into the pit lane to have a pit stop, that decision is being made all the way back in London, all the way back in England, inside this room. And so we have to make sure we know exactly what's going on, and we keep that connectivity running all weekend. Now, the way that happens is through a big decision-making tree. They take in all the individual elements from the gearbox, from reliability, from tires, through domain knowledge expertise. They take in live data from simulators being run, like the gaming simulators. They take in historic data. McLaren have an archive of over 40 years' worth of racing data that they take into these decision-making models. They take in the live data coming from the cars and ultimately feed that through to the race engineer who will discuss it with the driver. I can tell you now, if you're doing 200 miles an hour and your head is under 4G in force, you don't want more than one person talking to you. You just want one person, and that's your engineer. And so they will use all of this information coming together to help you go out on track and get the fastest lap possible. When I look at that, it feels a little bit like what we're up to here at Cisco. It feels like my old team and the way we used to work is now how we're working here at Cisco. Through those networks that we don't own, through the infrastructure that's not always ours when we're connecting back to the UK, using things like threat intelligence. We have those engineers stood around the track trying to spot the weather. We have things like Talos going out and spotting threats inside the markets. We have different applications, telemetry, your apps, cloud infrastructure devices. And when you bring all of that together and use the power of something like Splunk, you're able to start driving decisions and data-led decisions inside your business. And so to me, this feels very much like how we used to race as McLaren is now how Cisco are going out there as one team coming together to bring all of that insight from the wind tunnels, from the tires, from everything you're doing, from threat intelligence, from user data, all of it coming together into one platform allows you to go out and execute your race strategy or the way you go racing. If you get all of that right, and keep everyone connected, keep them safe and secure, give them the lowest latency network possible, give them AI to make decision-making, keep it all protected, and ultimately you can go out and try and win your version of your championship. Now, last year, the McLaren team had an incredible season. They went and won the championship, but it came down to a 2% difference in the last race. 2%. 23 races, 9 months of activity, all of that simulation, all of that data, all of those part changes, and it came down to a 2-second pit stop. You have to make sure it encompasses the whole team. And we have to make sure it encompasses the whole team at Cisco to make sure we can go out and help our teams, help our sponsors, help our customers go and do things like this, which becomes pretty special and pretty fun. But just leaves me to say thank you very much. It's been a pleasure to come and speak to you this afternoon. If you see me around and want to ask any questions, please do. But otherwise, thank you very much, and I hope you enjoy the rest of Cisco Connect. Thank you.